Hello friends, welcome to ITS workshop. In this video we would like to talk about more about Hadoop. So in last video we have seen what is big data. Big data is a problem and it's about dealing with pretty large amount of data. And Hadoop is one of the best solution for big data problem. So let us see what is Hadoop. The agenda is what is Hadoop, Hadoop cluster, and history about Hadoop, what are the principles which is for Hadoop cluster or Hadoop system you can say, and how we can compare with the traditional RDBMS systems, relational database management systems, and what are the different vendors for Hadoop. So what is Hadoop? Uh, Hadoop is a reliable, scalable platform for storage and analysis. So when we say Hadoop, it's not just about one framework, and it's about full ecosystem containing different projects. And this is reliable, this is fault tolerant, and this is scalable. You can scale Hadoop from 10 nodes to 1000 nodes, and it is used for storing large amount of data and performing analysis on large amount of data. So Hadoop is useful into that, and you can say consider it as a second generation data analytics tool in distributed and parallel programming. So like Teradata came, and now Hadoop, and in like coming days and in real-time analysis Spark is there. So Hadoop can be considered as second generation big data analytics tool. It runs on commodity hardware. So this is one of the advantage of Hadoop, that you don't need fancy hardware for this. You just have some cheap commodity hardware and you can configure your Hadoop 5 node Hadoop cluster, 10 node Hadoop cluster, and it is open source. You can use it without license, without paying amount. You can use it and you can contribute to its code. So this can be considered as a typical high level architecture of Hadoop cluster. It can be from 4 node, 5 node, and n number of node. There can be n number of node. Right now people are working with 10,000 node, 50,000 node. Big companies, those are working with that. So you can say that you can configure your Hadoop with n number of nodes. You can replace node anytime, you can add node, and you can remove nodes whatever you want. And we'll see this architecture again in depth. Right now you can consider it as client node or the name node, and secondary name node is contacting with data nodes. So there are a number of nodes. So this is client is requesting, and name node is a kind of manager for all nodes, and data nodes are where our actual task is getting performed. So Hadoop cluster, if we talk about a general term cluster, first we need to think about servers. So in hardware terms, server is a pretty powerful machine, and in software terms, if you think server, that is something which is available for entertaining the request coming from client or user. So if if there is any request coming from client side, then there must be some software who is entertaining that request, who is providing response, that is server. And when we have server, similar type of server, those are performing same task, when we collect together, like you can see in this picture, this is one data center's picture. this is rack. So on rack our server are put, on rack different servers are put, and when these servers are networked together and they are performing same task, each server is performing same task, then we can consider it as a cluster. So servers performing same task together can be considered as a system, and that system is known as cluster. So Hadoop can be configured using cheap commodity hardwares. Now, when we say cheap commodity hardware, it doesn't mean that we are just combining our desktops. It's not about a regular desktop, but it is about servers, real some cheap server or average cost server. You don't need like very expensive configuration or supercomputers for performing large amount of calculation, complex calculation. You just configure your inexpensive servers and create Hadoop cluster for it. So let us talk a little bit about Hadoop history. So how it came. Hadoop is named after an elephant toy started as a sub-project of Apache Nutch. So duck cutting and his team. So duck cutting son has got fun stuffed toy and he named him Hadoop. So it's just like, it's not acronym for anything, but it's just like some term which is not representing anything. It was easy to pronounce, so he just took this name, and for this technology he put the name Hadoop. And Apache Nut's job is to index the web and expose it for searching. So it's kind of open source alternative for Google. They started working with Apache Nutch, duck cutting at his team, and in 2004 Google publishes Google File System and MapReduce framework papers. So Google released some white papers, then duck cutting and Nutch team implemented those Google's frameworks, those white papers in their project Nudge. In 2006, Yahoo hires duck cutting to work on Hadoop with a dedicated team. So you can say that in 2004 they came up with this idea, and by 2008 they it went in production. So then in by 2008 Hadoop became Apache top level project, and people started using it by 2008. And nowadays you can see like most of the companies, you can name it, all companies are using Hadoop. There can be analytics based company, infrastructure based company. You can name Amazon, Oracle, Google, Facebook, Twitter, eBay, all e-commerce companies you can consider. So those are using Hadoop in some way or other. Now Hadoop follows some of the basic principles. So first principle we can say scale out rather than scale up. So what is the scalability, and Hadoop, why Hadoop consider scale out scale out principle, why not scale up principle? And second point, we want to see how it is bringing code to data rather than data to code. So taking data to your code is the traditional approach, and Hadoop is following the approach of bringing code to data. The third principle, it works on fault tolerance. So sorry. So HDFS is there, and how HDFS is fault tolerant in comparison to other system. And the fourth principle is abstract complexity of distributed and concurrent applications. So, like we have already discussed that Hadoop considers reading data from multiple disks. So, how to deal? So the programmer doesn't have to deal at the very low level of dealing with multiple disk reads and writes. He is just free to focus on business logic, and Hadoop is taking care of bringing all data together in correct form and intermediate results and then final result to the client. So Hadoop is taking care for that. So let us see all these principles one by one. The first principle, scale out versus scale up approach. So scale out approach is also considered as horizontal approach, and scale up approach is also known as vertical approach. So in scale up, we are supposed to add additional resources to an existing node. That is scale up. So if you have your system, you just make your system more and more powerful. That's the basic idea of scale up. And it follows Moore's law that can't keep up with data growth. New units must be purchased if required resources cannot be added. So if you cannot add more resources, if you cannot increase your existing resources capacity, you just replace your resources. And this is expensive and hard to implement. So traditional databases like Oracle, MySQL, and these solutions are following this approach, scaling up approach, making system more and more powerful. Single node, existing nodes more powerful. So that's kind of idea they are considering. And when we talk about Hadoop, you can say like Hadoop is not just making one machine more powerful, but it's bringing another node, so adding more nodes and machines to an existing distributed application. So that is kind of easy, and you can easily scale out, you can easily scale your architecture. You just need to add node. It can be 2 node, 5 node, 10 node, 50 node, like that. You don't need much powerful machine, and anytime you can take decision whether to remove some nodes and whether you want to add some nodes. And software layer is designed for node additions or removal. So if you are adding nodes to your system, it won't come it won't stop your application for performing any sort of task. So you don't need to have kind of replacement. You just add the server, you just add the nodes, and your work is done. Hadoop takes this approach. A set of nodes are bonded together as a single distributed system, and it is very easy to scale down also. Here it's not easy to scale down, but in Hadoop's case or scale out approach, it is easy to scale down. If we talk about scalability, you can consider the linear scalability is the ideal case. And scalability you can consider using this graph between load and number of machines needed. So we have number of machines needed, and this is computation requirement or load requirement for the system. So the linear scalability represents that whichever or whatever kind of load is coming, you just increase the number of machines and you'll be able to handle that load. So it's kind of 45-degree linear scalability. This is the ideal case. Ideally, this is not achievable. But if you talk about Hadoop, Hadoop system is near linear scalable system. And these are non-linear scalability. Even if load is coming and you are keep on adding different machines, still you are not able to handle much load. So those are kind of traditional system, non-linear scalability. So Hadoop can be considered in between both of these, near linear scalability. Now, what is the meaning of bringing data to code and code to data? So, data to code is the traditional approach. It, you can consider any data processing architecture, traditional architecture, in which nodes are divided into separate processing and storage connected by high capacity link. Now we are trying to access data every time. So many data intensive applications are not CPU demanding, causing bottlenecks in network. So we are just demanding datas, and we are transferring the data throughout the network all the time. So it kind of causes bottlenecks in the network. While the approach, which is you can consider this diagram, processing node, you are loading data and you are saving the result. So taking data and saving the intermediate result or final result. So the this is kind of rise of bottlenecks. This is kind of creating jam in the network. So loading data and saving the result, processing node is there, storage node is there, and so it is taking more and more your network capacity. While if you consider about Hadoop's approach is bringing code to data. So the traditional approach is about bringing data to code, and Hadoop's approach is about bringing code to data. So Hadoop automatically collocates processors and storage. Code is code is moved to data because uh, code is of tiny size comparative to your real data with which you are dealing, and processors execute code and access underlying local storage. So we are just sending the code to different nodes, and the underlying data can be taken from the local machine, and storage and CPU both can be taken from local machine. So this is full Hadoop cluster. This is Hadoop single node. It has got storage, it has got processor. So we are just sending code to each node, and then at these nodes, at these node, task is being performed. So we are taking data from here locally, and we are taking CPU locally, and then we are performing task. We are transmitting the intermediate result, and we are providing the final result back to the client. So these are the two different processes. Traditional system bringing data to code, and Hadoop system bringing code to data. Fault tolerance. So if we have large number of machines working together, then failures are common. It's not like exceptional. Failures are not exceptional in Hadoop, but failures are very common and expected thing. So Hadoop is designed in such a manner that it is supposed to handle failures very nicely. So there are two processes which Hadoop takes. Data is replicated. If you don't want to lose your data, just copy it somewhere. That's the idea which Hadoop follows. It has got 3 replication factor by default. So each data block is being copied 3 times, and then all 3 copies are put at different locations. So that's how it works. We'll see more about this in HDFS. And then if there are some task failure, then it retries the task. It tries to perform the task again if it is getting failed. So that's how Hadoop is fault tolerant. Abstract complexity. So a programmer doesn't need to worry about the complexity of handling all the system level approach. Hadoop abstracts many complexities in distributed and concurrent applications. So we just need to define a small number of components, and it provides simple and well-defined interfaces for interaction between these components. So we are just writing our mappers and reducers, and Hadoop framework is taking care of how mapper is communicating with the reducer, like that frees developer from worrying about system level changes. So we don't need to worry about system level changes. We can just focus on application development and business logic. So all processing pipelines, data partitioning, code distribution, race condition, data starvation, all these system levels processes are being taken care by Hadoop framework. So it kinds of abstract all the underlying complexities of distributed and parallel processing, and we can just focus on business logic. So it provides very good framework for that. Now if we want to compare our Hadoop system with the existing RDBMS systems, because some people still consider like, hey, what is Hadoop? Is it kind of replacement for your Oracle database or MySQL database? Then the answer is no, it's not a replacement, but you can use Hadoop in your existing architecture and it will work like a complement tool with your system. So you can do a lot of things with your architecture. So you have got RDBMS also, you can configure, you can connect that RDBMS to Hadoop, and you can perform analytics at larger scale also. So there are some points in which RDBMS is good, there are some points in which MapReduce is good. So if we talk about data size, RDBMS systems, when I say RDBMS, it means relational database management systems like Oracle, MySQL, these sort of systems. So they deal at gigabytes level. So we have some GBs of data, like 13 GB database, 14 GB database, kind of that. And when we talk about MapReduce application or Hadoop, then it is dealing with petabytes of data. If we talk about access, so traditional is interactive as well as batch processing. You can perform queries, you can see your result, you can write a result interactively, you can perform updation with your data, while MapReduce, traditional MapReduce approach is batch processing. You write once and you read many times. That's how you do it. So in traditional system, read and write many times whenever you want, but in Hadoop, you write once, like you have got 2 years data. So you just put the 2 years data and perform several analysis on the 2 years data. Now RDBMS follows ACID properties, while MapReduce are not supposed to follow any properties like this. And RDBMS should have a schema on right. So before you are going to create your tables or you are going to put your data, you should have a well defined schema. And it's not like you are changing your schema every time. And while MapReduce consider schema on read. So while you are performing analytics, you are reading the result, that time you can consider having a schema. Integrity, RDBMS provide high integrity with the system, while MapReduce provide low integrity. And scaling is non-linear. Obviously there is certain limit with the RDBMS system. You cannot scale up much. At one limit it gets stuck. But while MapReduce provide near linear scalability, keep on adding nodes and it will keep on handling your load which is coming to the system. For example, if we consider a website, so how you can think of Hadoop as the complement of your existing system. So we have got web server and we have got RDBMS over here and Hadoop over here. So first thing, we are utilizing our RDBMS to provide rich user interface and data integrity. So web server RDBMS can be provided for interactive applications, for kind of online transaction. You can say you are reading data, you are updating data, you are interacting with your database continuously. And RDBMS generates large amount of data for audit logs. So like one example, one use case can be auditing web logs. So these logs kind of use cases, so all those logs you are passing to Hadoop. So RDBMS is providing logs. Those logs are pretty useful if you want to perform some analytics, you want to get some insights from those logs. So you just perform analytics, then you provide result back to the RDBMS, which a web server can use. For example, suggestions based on audit history. So you have got logs and you are providing those, you are performing analytics and you are providing result back to the RDBMS. Then you can take some decision which can be useful for your business. This is how so Hadoop, here you can see Hadoop is not replacing the existing RDBMS, but Hadoop is complementing the existing system, and it's providing more insights for your large amount of data which is getting generated through RDBMS. So if we talk about Hadoop, it's not just MapReduce and HDFS. Obviously HDFS and MapReduce, these are at the core part of Hadoop. But when we say Hadoop, we are generally talking about full ecosystem. So there are a lot of projects going on with Hadoop. Those are working with Hadoop. Each of them has got different capabilities. So first of all, HDFS is there. HDFS is a file system, Hadoop distributed file system. On HDFS, we are using Yarn, yet another resource negotiator. And Yarn is not just Yarn is helping for distributed processing framework, and it's not just Hadoop is not limited to batch processing. So Yarn is handling that situation, and HBase is one of the NoSQL database, and it is column oriented database. So Hive is your SQL query kind of. You can perform, you can write interactive queries which is getting converted into MapReduce application and then coming to SDFS and then giving back result. OZ is your workflow, and Scoop is used for data exchange between MySQL database to your Hadoop system. Zookeeper is maintaining coordination between different nodes, and Flume can be used as log collector or streamlining your database. Uh, like you want Twitter data to be streamlined into SDFS, so you can use Flume in that use case. So these are different projects working under the umbrella of Hadoop ecosystem. So let us see some of them. SDFS, Hadoop distributed file system. This is different file system than the existing one. It considers as a unit disk for all the underlying nodes. MapReduce is a distributed data processing framework. So we can write our application and we are calculating, we are performing computation in a distributed parallel manner. And HBase is column database, so it supports batch and random read writes also. So you can query through HBase. So these are the projects which is making Hadoop more and more powerful. You can use these together according to your use cases. Zookeeper is highly available coordination service, which is putting coordination. Uzi workflow scheduler. Pig is a data processing language and execution environment, so useful for data scientists and data analytical people. Hive provides data warehouse functionality with SQL kind of interface. So let us see how you are going to use Hadoop in your system. So to start building an application, you need a file system. So we have got SDFS for that. So first of all, you take HDFS. Then addition of a data store would provide a nicer interface to store and manage your data. So if you have some interactive database, it is nice. So now we got HBase on underlying HDFS. So this is how your application is looking like. So we have got HDFS. Above HDFS we are putting HBase, which is used for interactive processing, because in HDFS you cannot do interactive things. This is just batch processing. But if you want to have random writes also, then you got HBase. Now for batch processing you need some framework. So why not using MapReduce framework for your batch processing? So we got HDFS. Above HDFS we have got HBase. Then we are using MapReduce for processing. After processing, there are some problems which requires coordination. Like one job's output should be supplied to another job. So Apache Uzi is a popular MapReduce workflow, and which can be used for coordination. So after MapReduce, we are using Uzi. Now MapReduce paradigm may not work well for analysts and data scientists. So data scientists won't be dealing as developer level. They won't be directly writing MapReduce programs. So Pig, they can use Pig, Apache Pig, and which is high level data flow scripting language. So it's very easy scripting language. They are writing their script, that script is getting converted into MapReduce, contacting to HDFS and giving back the result. Or Pig script can be directly dealt with HDFS. So this is how your architecture looks like now: HDFS, HBase, MapReduce, Uzi and Pig. Now you may have lot of good SQL expert in your organization, so you can consider using Apache Hive. So it provides a good data warehouse solution in which you can write SQL like queries. So if you want to write SQL like of query, you just write Hive queries and it will bring result from HDFS back to the user. So this is how your architecture is looking now. So this can be considered as typical example. There are other projects also, but this will give you a good idea for using Hadoop ecosystem in your existing architecture. Now Hadoop is open source. You can directly go to Apache website, you download your Hadoop, that we can also call it as plain vanilla Hadoop, and you start using that. But there are some distribution vendors, those are providing Hadoop solution. So obviously Amazon is providing their own big data solution, Oracle is providing, all big companies are providing the solution, but there are totally dedicated companies which are Hadoop oriented, and they are providing Hadoop oriented solutions like Cloudera. So Cloudera distribution for Hadoop, CDH is there, MapR distribution is there, Hortonworks is providing HDP, so you can also consider these. And they have got their own learning path and all lot of solutions for big data problem. So you can implement whether open source, you can build your own Hadoop architecture, and you can have these solutions. You are having both options. So this is what Hadoop looks like. If you need more detail, you can see the definitive guide, and this is how Hadoop works. It is reliable, scalable platform for storage and analysis. So if you like this video, please click on like button. Please subscribe, share for more videos like this.